Long Beach, California, is the second busiest port in the United States. It handles more than 9 million 20-foot container units, or TEUs, each year, with cargo valued at $200 billion. Yet existing channel dimensions and tidal delays pose limitations and inefficiencies for current and future deep draft vessel traffic. To transit the port complex, these larger vessels must carry a lighter load from their point of origin. This ultimately increases the nation's transportation costs by requiring more ships to move cargo into and out of the port complex. In 2016, Port of Long Beach officials began to address these traffic operation constraints and sought federal assistance from the U.S. Army Corps of Engineers, or USACE, Los Angeles District, to conduct a deep draft navigation feasibility study of the port.
And it's essentially an economic evaluation to look at alternatives to improve the configuration of the channel. The study was completed in 2021. And it was subsequently funded for design, so what we call the pre-construction engineering design phase.
To test various Port of Long Beach channel design alternatives, LA District project engineers reached out to the U.S. Army Engineer Research and Development Center, or ERDC, to run navigation simulations at its watercraft and ship simulator.
Port of Long Beach was the first time we used feasibility level simulation. This is the first time we broke it into two parts and did feasibility simulation, which we did back in either 16 or 17, and then the design simulation that Shannon and Richard did this past year.
We selected ERDC because it has a world-class facility for ship simulation, and we worked extensively with ERDC staff to get the model correct, both the actual geometry of the model, but also the hydrodynamics of the model, and select the proper ship or the design ship that the port will be using for testing.
The Port of Long Beach Deep Draft Navigation Plan was included in the Water Resources Development Act of 2022. The federal authorization has allowed USACE and the Port of Long Beach to move forward with the next phase of the project.
We worked closely with the USACE Los Angeles District team and pilots from the Jacobson Pilot Service, and we performed simulations here at ERDC CHL to evaluate a proposed navigation channel deepening and widen design. One of the unique things about this simulation study was evaluating wave dynamics that occur outside of the breakwaters at Port of Long Beach. And so that's the advantage of the ship simulator, is that we're able to optimize channel design and identify potential navigation issues before the proposed design is implemented in real life.
We've already, in this simulation, found a problem with one of the design features, and so we've expanded a turning basin based on the simulations we've had, and so it'll be safer in the future when the project is actually completed because of the simulations we did here.
Building rapport among all the key stakeholders was essential for generating quality feedback during the week-long simulations.
It's very important that we have good communication between the different parties, because the Army Corps are not ship operators and we don't know coastal engineering, and so the more we communicate between the different parties, the better the outcome, the better the product that's completed.
You really can't put a number to that. That's an invaluable piece of what we do here at ERDC, because we're able to bring those players together in a way that I'm not going to say it couldn't happen anywhere else, but when you throw in the fact that we have all of these experts with all of this tremendous amount of expertise in all the different disciplines across the ERDC, you're making a formula that you really can't repeat anywhere else that I know of. And so it's vital that we make that the best that it can be, and I'm proud that ERDC was able to be part of that, because we're impacting not just the Port of Long Beach, we're impacting the country, and really, when you look at it, we're really impacting the world.